is volumetric analysis. Volumetric analysis is a quantitative chemical analysis technique that measures the volume a material fills, or in more common usage, the volume of a second substance that combines with the first in known proportions to determine how much of the first substance is present. So what is the function and purpose of volumetric analysis? Chemistry labs in high school and college use volumetric analysis to determine the concentrations of unknown chemicals. A reaction happens when a known quantity of analyte is combined with the titrant. Students can compute the concentration of an unknown material by knowing the titrant volume. Hospital and medical laboratories use automated titration equipment for essentially the same purpose.
Here are the basic components of titration, which are burette, burette clamp, stand, flask, titrant, and analyte. The pipette here is to use for accurately measure of the unknown solution and transfer it to the flask. The burette is to accurately measure the known solution and add the known solution to the unknown solution until the reaction complete.
As for example, titration is a useful tool in biodiesel industry for determining a sample of vegetable oil's acidity. Researchers are able to calculate the amount of base needed to neutralize a vegetable oil sample. Similar uses for titration can be found in the food and petrochemical industries. For instance, the amount of unsaturated fatty acids in an oil may be determined by a redox titration. The amount of free fatty acids in an oil can be measured using an acid titration, and the amount of water present in a product can be determined using the Carr-Fisher titration method.
The methodology of volumetric analysis involves the following key steps. First, preparation of solutions. Prepare a standard solution, which is a solution of known concentration. This solution will react with the analyte, the substance being measured. Next, the setup of apparatus. Use a burette or precise dispensing instrument to add the titrant to a flask containing the analyte. The flask usually contains an indicator, a chemical that changes color at the endpoint of the reaction. Next, the titration process. Slowly add the titrant to the analyte while continuously swirling the flask. Carefully monitor the color change of the indicator. This indicates the reaction is approaching completion. Lastly, the detection of endpoint. The endpoint is reached when the indicator changes color, which signifies the analyte has completely reacted with the titrant. For greater accuracy, some titration use conductometric method to determine the endpoint. Next, calculation. Record the volume of the titrant used to reach the endpoint. Using the known concentration of the titrant and the volume dispensed, calculate the concentration of the analyte using the formula.
Here, I will explain the theoretical application of volumetric analysis in the food industry. This method is widely used to determine the concentration of analyte in a solution. Firstly, determination of acidity and alkalinity. Those will give effect on taste, preservation, and microbial stability. Next, analysis of nutrient content. It used to determine the vitamin C, which often use an iodometric titration method. And it used to determine calcium content in dairy product and fortified foods. Lastly, in food additive and preservative. The accurate quantification of food additive and preservative is critical for regulatory compliance and consumer safety.
We can use the Mohd method, in which sodium nitrate solution is the titrant to indicate the concentration of a salt content present in a food sample that has been dissolved in distilled water. Noted that food sample must be dissolved in water, as it is easier to extract salt from it. For your information, the Mohd method is the basic volumetric analysis that is used in the food industry as an analysis of precipitation titration, in which by the end of this reaction precipitates will be formed. In this method, we commonly use silver nitrate solution as the titrant and dissolved food as the analyte. Not to forget that the use of potassium dichromate as an indicator is important, as it plays a vital role in indicating the end point of the titration and making it observable. As a result, the reaction of silver nitrate with the food sample produces silver chloride precipitates as products. These precipitates can be extracted to calculate the concentration of salt present in the food sample. Furthermore, the additional chloride ions will then react with the chromate ions of the indicator potassium chromate to form red-brown precipitate of silver chromate. The titration should be stopped when the first trace of red-brown color is observed.
Now, let's see a few other examples of volumetric analysis and its importance. First, we have the neutralization of vegetable oil, where, in this case, scientists try to know how much base is needed to neutralize the amount of vegetable oil. This will eventually indicate the acidity of the oil. Next is the production of fruit juice. Volumetric analysis helps to measure the suitability of the acid content in fruit juice. Phenolphthalein is used as an indicator. Last but not least is the determination of sugar contents in beverages or drinks. The process is via titration, in which carbohydrates will be yielded as precipitates that can be quantified.
In conclusion, volumetric analysis is a crucial technique in the food industry for ensuring product quality and consistency. By accurately measuring the concentration of various components, it plays a vital role in quality control and nutrient analysis. For example, there are several companies that apply volumetric analysis for quality control and product consistency, which is Nestle and Kraft Heinz. That's it from us. Thank you.